Hi and welcome to the Optical tutorials. In this video we will cover the post-processing tools module in Optical. A very basic, very simple module, and this video should be very short, not much to cover. So it is very straightforward. You have simply two tools here, the virtual strain gauge and the virtual extensometer. Let's start with the virtual strain gauge. So I'm going to hit the button here, come onto the color map and simply draw a strain gauge. So I pick the center location and then I pick the shape of the strain gauge. So you can see that pretty much any shape is allowed here, any rectangular shape. And then like everything else in Optical, you can always adjust later. So I can click on the center here, bring it up. I can also click on an axis and rotate it if I wanted to. Okay. So very handy, very useful. Okay. So let's say I want it to be, say, normal to these cracks here. And you can grab any corner to adjust. And I want it to span these two cracks with my strain gauge. So this is it. You have the strain gauge parameters here. The width, the height, the origin. Everything here is expressed in millimeters, simply because in the format results module, we previously set up everything to be in millimeters. That's all. If you were to choose pixels here, you would read everything here in pixels. Okay, so then you can rename it by simply double clicking on it. And so that will be the left strain gauge, for instance. Okay, and you can create another strain gauge. You'll just populate that list, put it here and call it the right strain gauge. All right, you can also decide to delete, for instance, this one here and so on. So just right click on it and hit the delete strain gauge button and you're done. Okay, the second tool here is the virtual extensometer. So again, the name is very straightforward. It is an extensometer with a couple more features. So you just hit that button and draw your extensometer. So for instance, if I wanted to measure the uplift of this specimen, I would click here and here. And I can measure the elongation of this virtual extensometer throughout the entire test, right? And so again, I can change the name. I can call that left. I can put another one on the right-hand side. I can also put one across the diagonal. And I can click on the anchor points, change their location. If I want to zoom on it and make sure I pinpoint a very precise location like so, I can do that. And so now I can read the elongation. I can read the initial length here, the elongation here. So this extensometer elongated 1.5 millimeter during the test for this particular image at this point during the test. I also have the elongation in terms of projection along the X and Y axis. So that's something an extensometer would not give you in real life, but the virtual extensometer Optical can obviously do that very easily. The accuracy of these two tools will be a lot greater than simply looking at the color map because you're averaging over very, very large regions here. So the virtual strain gauge, if you're averaging over an entire coupon into a test machine, you could literally consider it as accurate as a real strain gauge. You could simply use that. And on top of that, it is like a rosette. It has the principal axis, the shear strain, so everything is done for you. Very handy, very accurate, very powerful tools. And again, extremely simple to use. There is not much more to say about them. Their name speaks for themselves. It is a strain gauge and an extensometer, to sum it up. Okay, last but not least, you can create a data table. So simply hit that button. It'll create a CSV file, comma separated value, which is really the standard to create data table. It can be read by Excel or Access, as well as MATLAB and so on. Any software pretty much, okay? So you just type a name, hit save, and it's gonna grow through every single image and compute the value for every single strain gauge and extensometer and store everything on a table. Very straightforward, doesn't take that long. A couple minutes though. Okay. So that's it for this experiment and for this module. Thank you for watching, and next module will be on the export options in Optical. Thank you very much for watching.